Hello, 7th grade. Nice to be back with you. Actually, I'm in my kitchen. I'm not sure where you are, but I hope you're doing well. This will be the last lesson that will be counted on your quarter 3 grade, which quarter 3 ends tomorrow, Friday the 20th. All work needs to be in by 3 o'clock, so do your best on that. I think I have until Monday to finalize the grades, just so you know. If you have any questions, you can email me privately or put it on the class stream. Okay, so this is not a new section in our book. It's actually on page 486 if you'd like to look at that. All of the examples, almost the examples I'm doing are from the book. We're going to talk more about operations with square roots. So remember that if you have two numbers under the square root sign, the radical, and you're multiplying them, you may combine them. So these two expressions are equivalent. So for example, the square root of 2 times the square root of 3 is the same as the square root of 6, and vice versa. That is true. But when you're adding two terms under the radical, you cannot add them together. So for example, the square root of 1 plus the square root of 4 is not equal to the square root of 5. The square root of 1 is 1, the square root of 4 is 2, so 1 plus 2 is 3. 3 is not equal to the square root of 5. This would have to be the square root of 9, right? So this does not work. Very important to keep that in mind. So let's take a look at two ways that we could simplify the square root of 15 times the square root of 6. And this is example 1 in your book. So notice in your book, they combine 15 times 6 and they get 90. So we have the square root of 90. And then if you remember the way that we want to simplify this number, so we want to say, can we factor this by a number that is a perfect square? And the perfect squares from 2 lessons ago are 4, 9, 16, 25. Those are the factors that we're looking for that might be factors of 90. So of course we know that 9 is a factor of 90. So 90 is equal to 9 times 10. We factored that. So the square root of 90 is the same as the square root of 9 times the square root of 10. And we factored 90 this way because the square root of 9 is 3. And then we know that the square root of 10 cannot be reduced simpler. The only factors of 10 are 5 and 2, and neither of those numbers are perfect squares. So the square root of 10 cannot be simplified any further. Well, I'd like to show you a different way. So I'm going to call this way number 2. And this can help you sometimes when your numbers get a little bigger. So this is optional, right? You don't have to do it this way, but you can. When you have the square root of 15 multiplied by the square root of 6, one thing you can do is create a factor tree and get 15 down to its prime factorization. Well, 15 is equal to 3 times 5. Those numbers are both prime. And 6 is equal to 2 times 3, correct? That would all be under the radical. When you factor in this way down to the prime factors, this is what you can remember. If you have a paired up root, a paired up factor, then you know that you can square root that because this becomes the square root of 3 times 3 is 3 squared times 2 times 5. And the way to look at this is whenever you have the square root of something squared, remember the square root and the square cancel each other out. So this 3 can come out front as a regular number. The 2 and the 5 are solo, flying solo. They don't have a pair, so we just have to leave them. 2 times 5 is 10. So one way might seem easier to you than the other way. Whatever method seems easier to you, I would suggest use that method. Okay, So we know that we cannot combine the square root of 5 and the square root of 7, right? We cannot say the square root of a plus the square root of b is equal to the square root of a plus b. We can't combine those. But what we can do is say, oh, I've got 2 square roots of 5, and over here I've got 6 square roots of 5. Those are actually like terms, just like if it were 2x plus 6x, I could combine those and get 8 of that thing. So combining this term with this term, we just add the coefficients. That becomes 8 square root of 5. And then again, this minus square root of 7. These are not like terms. We cannot combine them. And this is as simple as this answer becomes. That would be your final answer there. Okay, so then taking that a step further, let me try and keep that on the screen in case you're still looking at it. The square root of 2 and the square root of 18, you might say, well, forget about it. They're not the same, so we can't combine them. But wait, what we first have to do is say, can this be simplified at all? I'm thinking of 18 is equal to 9 times 2, correct? So we've got the square root of 9 times the square root of 2, and 9, the square root of 9 is 3 square roots of 2. In the front, 4 square roots of 2. So we have 4 of a thing minus 3 of that same thing would equal 1 square root of 2. And we don't need to write the 1 in front of it. So sometimes those can be a little bit tricky. So you can't just say, they're not the same, we can't combine them. You first need to simplify each radical. Of course, the square root of 2 is so small, that can't be simplified. But square root of 18 goes into the square root of 9 times the square root of 2, which becomes 3 square roots of 2. And then all of a sudden, we have like terms and combine them. All right, this is a little tricky. And the last thing that we're going to do here talks about rationalizing the denominator. So this is a convention. We talked about square roots of perfect squares, like the square root of 25 is 5, that's a whole number, but the square root of 26 would be an irrational number. If the number is not a perfect square, then this answer is irrational, has a decimal that repeats or never repeats and goes on forever. So this is just a convention in math. We never want to leave a radical in the denominator of a fraction. I'm not sure if you've seen this before, so I'm just going to walk you through step by step. Here's the example. We have the square root of 25 over 2. So you did a few problems like this before. You did problems where the bottom number was a perfect square and you could just square root it and get a whole number. They purposefully did not give you problems like this because this is a new technique that we have to do. So the first thing that I do is I say, hey, can 25 over 2 be simplified? Nah, that's 12.5. I don't want to deal with fractions. So I'm going to have to look at this a different way. I'm going to have to look at the numerator separate from the denominator. I know that this is true. I can break that up. Now the square root of 25 is 5. That's nice. But the square root of 2 is just the square root of 2. Cannot be simplified. All right, so here's our technique. Watch closely. How do I get rid of the radical in the denominator? Well, I know that if I multiply that radical by itself, the square root of 2 times the square root of 2 is a whole number 2. Of course, I can't multiply the denominator of the fraction. It would it would change this whole fraction, right? It wouldn't be 5 over square root of 2 anymore. But if I multiply this fraction by the square root of 2 over the square root of 2, which in itself is just equal to 1, I'm getting an equivalent fraction here. So I did the denominator, square root of 2 times square root of 2 is just 2, and in the numerator this becomes 5 square roots of 2. We can't completely eliminate radicals and fractions, but we can always eliminate the radical in the denominator. We never want to leave a radical in the denominator of a fraction. So this fraction is equal to this fraction, which is equal to this fraction. This is fully simplified. They're all equal to each other. We're not solving anything, we're just rewriting. All right, since this is probably the most confusing part, I've got 3 more examples for y'all. 1 over the square root of 3. Can this be simplified? No. So multiply top and bottom by the square root of 3. And this becomes the square root of 3 over square root of 3 times itself is whole number 3. Not simplified, simplified. Moving on, square root of 2 over square root of 5. Can either one of these be simplified? No. So therefore we need to multiply the numerator and the denominator by whatever is in the denominator, which is the square root of 5. And this becomes square root of 5 times square root of 5 is 5. Square root of 2 times square root of 5. Do you know what that is? It's the square root of 10. Now some of you might be tempted like, oh, 10, 5, can we simplify? The answer is no, because any number under the radical, you can't do anything with it with a whole number, a number that's not under the radical. I like to say, this guy is in jail, this guy is free, they don't interact with each other at all, never ever. So this is how we leave it. And then the last problem, I'm looking at 16 and 20, and I'm thinking, maybe I could simplify here, right? 16 and 20 both have a factor of 4. I'm going to just reduce this fraction first. 4 goes into 16 4 times. 4 goes into 20 5 times. Can I simplify anything else here? Well, the square root of 4, I can rewrite it like this. You don't have to. Some of you can look at this and go skip this step. But if you want to rewrite it, then you can see the square root of 4 is, I'm going to have to hop down here, 2. The square root of 4 is 2. And then I have the square root of 5. Square root of 5 cannot be simplified. I've got a fraction with a radical in the denominator. Therefore, I must do this step. Multiply by the square root of 5 over the square root of 5. And we would get 2 square roots of 5 all over whole number 5. Okay, your last homework assignment for quarter 3 is on page 487, number 1 through 15.